Okay, here we have a past paper question of vectors in two dimensions. This question is from May June 2021, paper 2-1, and question number 10. AB is given, that is column vector AB is given, that is -3 and 5. We have to find its magnitude. So to find its magnitude, we will use the formula under root x square plus y square. So it is equal to under root x square plus y square. So this is the value of x and y. Now when we substitute these values, here we have -3 square and plus 5 square. So 3 square is 9 and 5 square is 25. Now when we add these two, it is under root 34. Now we will take the square root of 34 and write the final answer. Because it is paper 2, so the calculator is allowed. So you will find the square root and write the answer in 3 significant figures, that is 5.83. So the answer is 5.83. Now in the next part they are saying AC is equal to 6,2 and C is the point 10 minus 1. So as C is the has a point 10 minus 1, so if we write its position vector OC, then it will be equal to 10 minus 1. Find the coordinates of A. So as we know that we have AC, so if we write in terms of position vector, we will write OC minus OA. Now we have AC and OC, so we can find OA. So we will get the coordinates of A. So AC is 6,2 is equal to OC is 10 minus 1 and minus OA. Now we will shift OA on the left hand side and AC on the right hand side. So 10 minus 1 minus 6,2. Now when we subtract this, it's 10 minus 6 is equal to 4 and minus 1 minus 2 is equal to minus 3. So we have got the coordinates of A as 4 and minus 3. Okay. Now next part we have, here they are saying B is the midpoint of AD. Find the coordinates of the point D. B is the midpoint of AD. So it means that if we have line AD, then B is the midpoint. So find the coordinates of the point D. So we have the coordinates of A. We are not having coordinates of B, but we have AB and the coordinates of A. AB is equal to -3 and 5, and the coordinates of A we have got 4 and minus 3. So if we write in terms of position vector as AB is equal to OB minus OA, so we can get the coordinates of B. So AB is -3, 5 is equal to OB we have to find, and OA we have got 4 minus 3. Now when we shift it on the left hand side, -3, 5 plus 4 minus 3, so we will get the coordinates of OB. So when we added, -3 plus 4 is equal to 1, positive 1, and 5 minus 3 is equal to 2. So the coordinates of OB is equal to, or coordinates of B is equal to 1, 2. Okay, so here I am writing the coordinates of B, 1, 2. Now we can use the midpoint formula to find the coordinates of D, because they are saying that B is the midpoint. So it means that if we apply the midpoint formula, x1 plus x2 upon 2 and y is equal to y1 plus y2 upon 2. So AB is A and D are the corners and B is the midpoint. So B is the value of x and y. So here we will write 1 and this is 2. Then x1 is the coordinates of A, this is 4, and plus x2 upon 2. x2 is the coordinates of D. Okay, then here we have -3 and plus y2 upon 2, Now when we simplify, x2 is equal to 4 plus x2, and 2 minus 4 is equal to x2. So x2 is equal to minus 2, then 2 times 2 is 4 is equal to minus 3 plus y2. So 4 plus 3 is equal to y2, and y2 is equal to 7. So the coordinates of D are minus 2 and 7. Okay. Now next we have this is minus 2 and 7. Now in the next part they are saying the diagram shows triangle OPQ, and OP is equal to P and OQ is equal to Q. R is the point on OQ, okay, and such that OR is equal to 2RQ. So it means if we write it in terms of ratio, so OR upon RQ has a ratio 2 and 1. So it means the sum of the ratio is 3. So OR is basically 2 upon 3, and this is 1 upon 3 of OQ. Now S is the midpoint of PQ. Okay, S is the midpoint, so it means that these two sides are equal. Now in the first part they are saying find PQ. So we have OP and OQ. If we write this in terms of position vector, it is OQ minus OP. So OQ is equal to Q and OP is equal to P. So Q minus P is the vector PQ. Now what is next? Here we have Q minus P. Now in the next part they are saying find OS. Okay, so now to find OS, if we take a triangle OQ plus QS, or we can take, to find OS we can take OP plus PS. Both are correct. If we join these two, O and S, you can take either OQS triangle or OPS triangle. So both are correct. When we apply triangular law, we have got the OS is equal to OQ plus QS, or either OS is equal to OP plus PS. So you can use any one from here. If you use the second one, like OS is equal to OP and plus PS. So see, OP is equal to P and PS. S is the midpoint of PQ. So if we divide PQ by 2, we will get PS. Okay, so plus half of PQ. So P plus half of Q minus P. And if we take an LCM, so 2P plus Q minus P upon 2. So 2P minus P is equal to P plus Q upon 2. So OS is equal to P plus Q upon 2. Here we have OS is equal to P plus Q upon 2. Now the last part is SR. Now we will find SR. So SR is here. If we join S and R, this is SR. Okay, to take this triangle, to find SR, we can take OSR triangle, or we can take SQR triangle. It's up to you that whatever triangle you want to take, you can take that. Okay, here we have OR. OR will be equal to 2 upon 3 of OQ. Okay, and it is 2 upon 3 of Q, because OQ is equal to Q. We have just got OS, and OR is equal to 2 upon 3 of Q. Okay, so if we take this triangle to find SR, here we have OS. So to find SR, if we take triangle SO plus OR. Or in terms of position vector, we can write OR minus OS. We have OR, we have OS. So OR is 2 upon 3 of Q, and OS we have just got, that is P plus Q upon 2. Now if you take an LCM and simplify, LCM will be 6. So 2 times 2 is 4Q minus 3P plus Q. Now this is 4Q minus 3P minus 3Q upon 6. Now 4Q minus 3Q is Q minus 3P upon 6. So SR is equal to Q minus 3P upon 6. So move this, Q minus 3P upon 6. So we have got this answer, Q minus 3P upon 6. Okay. I hope this question is clear to you. Thank you.